All right, so we're going to learn the law of cosines. Here's a triangle. So what I'm going to do right now is I'm going to make straight up and down line, a perpendicular line. It's called an altitude for all you geometry students. It's perpendicular, so it makes a right angle right there. And let's label some of the sides. Let's label that A. Let's label that C. B is that whole entire side right here. Okay, in fact, let me just do like this. Okay, so that's B right there. And let's see what else they tell you. Let's make this a different color. That's X. X is from this point to where that perpendicular line hits. Everybody see that? That's what X is. So what do you think that little part right here that's left over is? I'm not going to give it just another name. I'm going to use some of the letters that are involved in here. So watch, the whole entire side is B. This little bit right here is X. What do you think we're going to call this part right here? No, I said it's not going to be another letter. It's going to be letters that we've already used in here. It's not just going to be one letter. BX? Think about it. Look, I'll make this easy for you. What if B was 10? What if X was 7? What would this little bit right here be? What'd you do? What math did you do in your head? Give me the numbers. Tell me what math you did. 10 minus 7. Well, I don't know this is 10, and I don't know that's 7, but I do know this is B, and I know this is X. Not over, minus. This would be B minus X. Everybody see that? So I'm using the same letters that I was given, but I can write this in terms of B and X. It's B minus X. All right, so just substitute numbers in, if you're not sure about how to get that. All right, are we good so far? Oh, not quite yet. Let's label. Let's do this in a different color too. I don't know why, just to make it pretty. So what would this big angle right here be? If this is side A, what do you think this angle is? How about capital A, right? If this is side C, what's this angle down here? This would be angle C. And if this is side B, what would this big old angle up here be? It would be B, right? So there you go. So it's all labeled, nice and pretty. Everybody with me so far? What we're going to do is we're going to do some stuff with it. And, oh, I had more room. Let's push this up to about right there. We might have enough room here. And let's just do this writing stuff in white just to make it a little easier. So what we're going to do is look at, oh, by the way, I'm sorry. I need to label one more thing, and that would be this one. We'll call this D. There's no little d here, but we'll just call that point D right there. Everybody with me all right? Okay. So follow along. Let's see what we hit. Let's take a look at BDC. See this little tiny triangle right here? It's a right triangle. Agreed? Watch what we're going to do. We're going to do a little Pythagorean theorem. Oh, almost forgot. Oh, I'm forgetting all kinds of stuff. That line right there, let's call this H. Why in the world would we call it H? It seems kind of random. Because it's the height, right? It's the height of the triangle, exactly. So really, it's not random at all, is it? Stands for the height. So now, what we're going to do, you may not understand why we're going to do this at first, but you'll see that it works out. So let's just play along. Everybody watching? Okay. I'm going to do Pythagorean theorem on this triangle BDC. So if I wrote this as Pythagorean theorem, what did I say? Quarter of, right? Oh my, it's going to be pushing it. So I'm going to go fast. So watch. I'm going to write h squared plus, actually let's do this. Let's write a squared equals h squared plus b minus x squared. Would you agree that you could do that? It's Pythagorean theorem, okay? Now, what we're going to eventually get, I'm just going to do I'll just leave out some of the steps. But if you multiplied all that through, you would get this. You would get b squared minus 2bx plus x squared plus h squared. Okay? Now what we're going to do is take a look at this left triangle. We can do Pythagorean theorem on that as well, couldn't we? So I could say that c squared equals what? On that left triangle, that ADB. Anybody watching? Listening? Paying attention? We got that. Would you agree? Yeah? All right. Let's take a look at this thing over here, what we started on the left. Do you see this thing right here? Do you see it over here? What do you think we're going to do? This is equal to c squared, so instead of writing this x squared plus h squared, we could write it what? We could put a c squared in there. That's right. Okay? You're probably thinking, where in the world are you going with this? Well, you'll see. All right, so we have that so far. Now, what we're going to do is go back to this little triangle. I'm sorry, go back to the big triangle right here. And what we're going to do is we are going to actually kind of solve for angle A by using a trig function. So we are going to use, we don't know, I'll just do it. I'll just show you because I'm running out of time. So I'm going to take the cosine of A. So if I took the cosine of A, because we are going to learn the law of cosines, right? So that's a good thing to use. So we're going to take the cosine of A is equal to what? Adjacent over hypotenuse, correct? Which one is the adjacent to angle A? That would be x, and the hypotenuse would be c. What we're going to do is we're going to solve for x right now. So x equals, multiply both sides by c. So it's c times the cosine of A. All right, you with me so far? Everything I've written down is true, isn't it? Yeah, everything I've written down is true. I'm just going to show you how it all works out. So there's an x right here is equal to all this stuff. Do you see an x over here? So guess what we're going to do? We're going to take this c cosine of A, and we're going to replace that x with it. You tell me if I'm going to make a mistake here. I think everything we've done so far is good. So it's 2b. Now, instead of x, what are we going to rewrite? What are we going to put in terms of x? C cosine of A. We're getting there, I promise. We're almost there. To tell you the truth, you don't even need those parentheses there. What's that? Yes, I did. Thank you. See, that's why I told you to keep track of me, because sometimes I mess up. All right, so we don't really need those parentheses there. There's no distributing or anything like that. Now what we're going to do is, let's see, I think that's everything we need. Minus 2a. Yep. This is kind of the law of cosines, but I'm going to make it a little bit prettier, okay? So what I'm going to do, I'm going to rewrite it. I'm going to write a squared equals b squared. So far, everything's the same, but I'm going to put those squareds together, okay? So I'm going to just take that c squared and put it over here with this. And then I'll put the rest of it here. 2 minus 2b cosine of A. That right there is one of the forms of the law of cosines. It's not really the one that we learn.
Isn't that c cosine of A?
Yes, because I'm looking at the wrong thing. Actually, 2bc cosine of A. Yes, correct. Since the two c's were next to each other, I kind of mixed it up. That's correct. So that's kind of the law of cosines. But what we're going to do you remember how we did this with the law of sines? We kind of had different arrangements of it. So you could write it like this. You could write it in terms of b. So watch what we're going to do. Instead of a squared equals all this, let's figure out what it would look like if we wrote b squared is equal to all this. So so you got ABC right here? Well, there's your b already, so what do you think you're going to have in here? You're going to have an a and a c. They're squared. Minus, instead of bc, we're going to have a 2 what? AC. Instead of cosine of A, because look, the cosine of A matches up with this number that's over here by itself, what are we going to put here? Cosine of, what do you think? B. There you go. And there's another form of the law of cosines. Most books, though, write it the way we're going to write it next. Most books use the c. I don't know why. They just do. All right, but any of these will work. So most books write it like this. Everybody watching? C squared equals, what do you think? A squared plus b squared minus 2. And then you use these two right here, AB. And it's the cosine of whatever the angle to that sine or that length is right there. So it's C. This is the one that most people would, if you ask somebody on the street and said, yo, could you tell me what the law of cosines is? I really got to know. This is probably what they would tell you right here. They would probably use that one. But really, they're all exactly the same. I have 5 minutes. Let me show you how to use it. Okay? Oh, man, I have 2 examples. Well, goodness. I don't think I'm going to have time to do both examples. What I'll do is this. I'll add it to this lesson. All right, so if you want to see the second example, you can watch the lesson and I'll have it because I just don't have enough time right now. I only got 5 minutes. So here's a triangle. Takes me forever just to draw the thing, but all right, so that's what that triangle looks like. Let's put some stuff in here. So this is triangle ABC. And they tell you that this side is 24. They tell you this side is 18. And they tell you this is 57 degrees. All right? And they ask you to solve the triangle. So they ask you to find all the missing stuff. So this 24, what letter would we give this 24 right here? B. What would we give the 18? A. And then this side up here would be side C. All right, so that's what we're looking for. We're looking for angle A, we're looking for angle B, and we're looking for side C. The thing about this, you would not be able to use a law of sines to solve for this, would you? You don't have enough information. You don't have 3 of those 4 things. So you got to have another way to do it. And law of cosines is the way to do it. So what I would do is this. Since you know this angle and you're looking for this side, I'm going to put c squared equals a squared plus b squared. Well, we know both of those, don't we? So 18 squared plus 24 squared minus 2. And then you just take those same 2 numbers, 18 and 24, and multiply them together. And take the cosine of whatever the angle is opposite that side right there, which is 57 degrees. There you go. You just did your first law of cosines. Plugged it all in, and now you just got to put it in a calculator. To tell you the truth, the hardest thing about doing this is probably putting it in your calculator and getting the right answer. Again, I'm not going to sit here and show you how to do it all in the calculator. Remember, this is c squared. So once you get all this in your calculator, what are you going to do to that number? You're going to take the square root of it, right? Okay, make sure you do that. Everybody got that? So just be careful. All right, put it in your calculator. Make sure you put parentheses if you need parentheses and that kind of stuff. And then you should get C is approximately 20.7. All right, so put that in your calculator and see if you get 20.7. You should. Now that you know this is 20.7, now you could actually use the law of sines. So even though this is a law of cosines worksheet or problem, you can still use the law of sines to find one of these other angles. Okay, I'll set it up for you because the bell's about to ring in a minute or two here. So if I wanted to find one of these angles, let's find A. So I'm going to write sine of A over side A, which one's side A? 18. Equals, now what do I know? I need to know an angle and a side. I'll do the 57 again. So I'll go sine of 57, give me a second, over what? 20.7, which I just found. Okay, I wouldn't have been able to do that at the beginning because I didn't know side C was 20.7. You do the math on that, and you get approximately 47 degrees. So if this is 47 degrees, how would you find angle B? Angle B is easy to find. Okay, it's just 180 minus 57 minus 47, which we just found, and that will give you 76 degrees. And that is how you do a law of cosines problem. Yes?
You're finding C.
Yeah.
Do you do the cosine of 57 with just that?
What calculator are you using? Let me see it. Okay, so what I would do is this. I would go 18 squared plus 24 squared.
I got that.
Okay, minus. And then what I would do is put a parentheses right there. Because you're going to put all that stuff in a parentheses.
I did that separate, and then I...
You could. You could if you wanted to, but if you wanted to do it all in one shot, I would go here, punch it in there. Ready? 18 squared plus 24 squared minus parentheses 2 times 18 times 24 times 57 cosine, close the parentheses, hit equals, and then take the square root, and you should get 20.7.
Yeah.
Okay? So this is the key right here, putting a parentheses. Now I put a bracket, but you got to have the minus out front, okay? But put a minus and then put a parentheses here, a parentheses here. Why did everybody leave? I didn't give a worksheet out. Here's worksheets. Don't throw them on the floor. Yesterday somebody threw them on the floor. Okay, so take a worksheet and you're doing 1 to 15. 1 to 15, okay? So for those watching, and I'll do the other example and then tag it onto this lesson. Okay, so it should be on there in a little bit.
Wait, so to find that, like, the degree, just you switch the law of sines and to find it since you have 4 out of the 3 other things.
Yeah, exactly. All right, so it's like a combo problem. It's not just law of cosines. Well, I knew I was running out of time, but I don't know. I think it's important to go through like how we got it. A lot of students don't think that, but I think it's important. So that's why I did it.